Hello, for today I'm going to be explaining the question 4 and question 5 for the Emath1 Excel assignment. I'll start with question 4 part A. So for question 4, we are going to move from the standard form of a quadratic equation, which is a squared plus b plus c. So to identify the specific features, the roots, x-intercepts, and the vertex form. For part A, which is the x-intercepts. To find x-intercepts, we use the quadratic formula in Excel, the Excel version of the quadratic formula, which has the setup, which I have set up to read the values of IBM, AB, and C from the start cells, which are the ones I pointed out over here. So by using square root G4 square root G4 times 2 to the power of 2 minus 4 E6 and E4 and I4. The formula automatically calculates the discriminant. The discriminant, which is over here. If the discriminant is positive, then the sheet updates these IBM x bracket 1 and IBM x2, which are these two, x1 and x2. So they will adjust the values constantly whenever I change my inputs, the inputs that are up in these numbers here. So for part 4b, the vertex form. For vertex form, IBM y equals to a x m to the power of 2 plus n, which is this number over here. So we need to follow the turning point. Calculated IBM bracket m as IBM bracket fraction b bracket fraction bracket b bracket 2a. The horizontal shaft, and IBM n as the function value. IBM n is the function value at the point of the vertical shift. Showing the formula in the cell demonstrates how Excel acts as a calculator to transform the function's appearance while keeping its mathematical behavior identical. So now that is part 4 finished. I'm going to be explaining question 5. Question 5, which is improving the curve fitting for the visual strategy. And show the graph. This is the graph that we're going to explain. And the problem with trial and error is great for getting a feel for the IBM A and B. Yes, getting a feel for the A and B. And C also. So it charges the parabola. For example, charging IBM A, adjust the width and the opening direction of the graph, while changing C would move the vertical intercepts. So the precise method to improve upon manual guessing I used a more systematic approach. Since I have a specific point on the target curve, like IBM 2, like these numbers over here, I can use that point to create an equation. The logic by identifying the vertex IBM H and K, these numbers, the vertex of the target curve from the graph, I can substitute into the vertex from IBM y equals to a bracket x to the power of 2 plus k. Then I plug it into the known point IBM bracket 2.0 point 2 the 2 comma 0.867 bracket to solve for the unknown coefficient IBM A. Okay, thank you very much. Those are question 4 and question 5 explained.